This is assignment 2. It's due Monday by midnight essentially. It's got two parts. The discussion question. This is participation only. 1 point. Hopefully you're enjoying that discussion. And then we're going to have a download. So let's click on this is assignment 2 on Nearest Neighbor Networks. And it's APM assignment2.zip. Let's download it. I like the one with the green arrow. So we click here, and then down in the corner we'll see it starting to download. Once it is finished downloading, we need to open it. So we can click there and then click on Open. That'll bring this up and it'll say Extract all files. Now I'm in Windows. It may be slightly different in your operating system. Let's do Extract all files. And now these are the extracted files. We're going to upload all 4 of these files to the Sage Math Cloud. So I'm going to put these in my Predictive Analytics folder or project. So I want to hit New. That will bring up this dialog. Now I can click on this big gray box and do a file browser dialog, but I'm going to simply choose these 4 and drag them over to the gray box, and that will upload them. The movie lens data, you'll notice, is large, so it's going to take a minute. And then if we go back to files, you'll see we've now uploaded these files. We want to work in the notebook, this apm-assignment2.ipynb. We'll open it up. And as you can see, you'll need to execute. It'll look a lot like the notebook for assignment or for module 3. It's going to have these built-in questions, so you'll want to save often. Now it saves automatically, and when you're ready you can simply download the notebook. Go here and download as IPython notebook, and then put it in the Dropbox. There are 3 activities. The first is an overfitting exploration. And what you'll be doing here is you'll start at k equals 3, and there are 5 points that show up when you execute this command, display data 2D. This is we've seen this in the last one, but the way we get that is you'll have to put in your username. I put in nicely J, and then you'll have to execute this line %run -i. The -i there inserts it into the context of the notebook rather than simply loading it into Python in the kernel. This puts it both in the kernel and in the notebook. Assignment2.py, and then that gives you the ability to execute. And you see we have 5 points. A certainly should be class 1. B probably. C maybe class 0, maybe class 1. D and E probably definitely class 0. So based on the nearest neighbors concept. Now we're going to look at what's called overfitting, and we're going to get overfitting in the sense of if we increase k, therefore increasing the number of neighbors used to determine the classification of B, eventually even the E here that's completely touching it, looks like this class 0 point, all 5 of these points will be in class 1, and that will certainly be overfitting. We'll use too large of a network, too large of a value of k, and we're now predicting everything's in class 1 when obviously something should be in class 0. And you want to stop when you get to the first k for which everything is predicted to be in class 1. Activity 2 also worth 3 points. The first activity was worth 3 points. This is the movie lens data. And in the movie lens data, you're just going to get some experience working with large data. There's really nothing to do here except execute. And at the end, we're going to go through talking about using a sparse matrix, and at the end I'm going to ask you a question, which is essentially, if we had not used the sparse matrix, what would have happened? Activity 3 is a set of data with missing values. Again, once you've loaded that assignment to pi, this is defined. You notice there's a lot of missing values there. We want to impute those missing values. I know what they should be. Here are some ways of doing the imputations. Here's some examples. Here's an example of an k nearest neighbors graph, and here's an example of the imputation, and then you can score that imputation. So your task is to get as close to 1 as you possibly can. And then finally, we're going to do recommendations, a recommender system, and you essentially will keep executing this until you get good recommendations, and then you'll be finished there as well. If you have any questions, feel free to ask, and I'll be glad to work with you. You can also collaborate. Let me just go ahead and show you how you would collaborate. So when you have a project, it has settings, and in settings you can go to collaborators, and to collaborate with me you would simply type in my email address, and then you would hit the search button, and it won't bring anything up here, but if you hit the search button in yours, it will bring me up, and you can add me as a collaborator.